Hi everyone, welcome back to the Docker security series. Today we are going to discuss about one of the important topic. On the Docker security best practices. Okay, so before going to discuss about multi-stage Dockerfile, so we'll discuss about what exactly the problem. Okay, imagine you are working on a X company. Okay, so you are working on a X company, and your developers. Okay, so your developers is writing some Python application. They are developing some Python application, right? Okay, so they are developing some Python Flask application. Okay, so they have developed that application, and then developers has created Docker image, and then that Docker image has been um, deployed onto the production. Okay, so onto the production. So the developers written the code Python application on the Python. Okay, so they have created the Docker image. Okay, so and then they have deployed the application onto the production. Okay, so it is working fine. It is working fine. So everything is working fine. So the customer is able to access that particular application, right? So once this application is moved to production, one of the team, the security team, okay, the security team has scanned this particular image. Okay, they have scanned this particular this particular Docker image. Okay, so using some kind of tools called Trivi tools called Trivi. So and then this Trivi reported there are 400 vulnerabilities in your application. Okay, so these vulnerabilities maybe from your application code, maybe from your application code, because you write 10% of code and you will get 90% of the code from the open source libraries, right? Open source. So we don't know what exactly there in this open source code, right? Okay, so maybe you written the 10% code perfectly. There is no chance to have the vulnerabilities in your code, but we don't know what exactly there in your open source libraries. Okay, and also you build a Docker image, you use base image base image. Okay, maybe this base image have the vulnerabilities, right? We don't know what exactly this image how this image has been built. Okay, this image has the OS, so OS has OS related vulnerabilities, and some tools which are related to that particular OS might be having older kind of tools. Okay, libraries. So maybe that um, tools plugins are having the vulnerabilities, right? So these are the chances where your application got um, um, like having the vulnerabilities, right? So this security team inform these developers. So your application is having vulnerabilities. Okay, so what happens then? Developers will be in shock, right? So they'll be thinking, so I have written 100% of secure code, I'm sure there will be no vulnerabilities. Okay, then how these vulnerabilities came from, right? So maybe they are using this Docker image as a it come from base image, or it can be from open source libraries, right? Okay, so in this video we are going to learn so how to use this how to secure your Docker image. Okay, so you have to think about base image, like what kind of the tools it has, what kind of OS it has. You have to think. Okay, so that's what the you can also using this multi-stage Docker multi-stage Docker file. So you can reduce the image size, and you can image size, and you can reduce the security breaches, right? Okay, so how we can implement this multi-stage Docker file. Okay, so we are going to learn this topic today. Okay, so you understand, right? Like, so how we are going to get the vulnerabilities. So application developers has written like the good code, there is no chance to get the vulnerabilities, but there might be a chance from one open source libraries which they are using, and there might be a chance getting the vulnerabilities using the Docker image base, right? So they'll be building single Docker file. Okay, single Docker file, and single stage Docker file. So where will be they using, like for example, Ubuntu. Okay, so we don't know how this Ubuntu has been built. So inside this it has the cell access, right? It has different plugins, libraries, file system, so everything will be there, right? We don't know OS files, so everything will be there inside this particular the single stage, whatever the base image you are going to use, right? So this is how we are going to see how to write a multi-stage Docker file, and how to secure our Docker image. Like securing, like creating the secured container is not only the point to be considered, right? So you need to consider from the base how you are writing the Docker file. Okay, so how you are writing the Docker file, how you are building the Docker image. Okay, so so you will be getting these vulnerabilities, right? Okay, so there might be a chance, like, so the operating system vulnerabilities, right? So which they are using some packages, like installing some packages like m update, those kind of updates we install, right? Unnecessary packages. So, and the tools, libraries we use inside the Docker image, right? Inside this base Docker image. Okay, so this might be the reason, like, so where we are getting um, uh, the vulnerabilities in our application. Okay, so let's see, we can see how we are going to get those vulnerabilities, right? Okay, so like for example, we have this particular application, sorry, we have this particular application. Okay, so we have this code which as written by the developers. Consider this code has been developed by the developers. So let me write some test.py. So generally they'll write some test files, right? Like, so which they'll testing their the code, whether that particular functionality is working fine or not. So I'm just writing something actually. Okay, so nothing else. Okay, so and and also I'm just creating .env file, so where I'm going to put all this data. We have already this file, and we have Docker file, and let me create readme dat file as well. So let me readme dot md file. Okay, so where I'll write multi-stage 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 Docker file. Okay, so we have written Docker, like, so when you clone your code, right, from the Git repository, you will be having .git as well, right? So let me create .git, for example. So sorry, some just code I'm just writing. Okay, so nothing else. Sorry. Um, um, okay, so I'm just clearing the scene, and we have these many files, right? Okay, so we have these many files in our project. Okay, so let me open the app.py. So how this code look like? So they have written this particular Python application. Okay, so let me go down and we can see. Okay, so we have this particular code. Okay, so and then we have the requirement.txt, and we are going to we have the Docker file as well. Okay, so how they have written the Docker file, like, so let me open the Docker file as well, like let me copy, let me see this. So let's see, they are copying this complete files. Okay, they are copying a complete files here. Okay, they are copying the complete files here. Like, let's go ahead and see. um, Let me go ahead and build docker build hyphen t, so demo app. I'm just giving the version, so let me go ahead and okay, so we got this because of Docker. We haven't started it actually, so that's the reason we got that error. So let me open this Docker. Okay, so now let me build it. Okay, so the Docker image has been built. So Docker images. If you see demo app which we built, so this is the image. Okay, so this is image which we have built, right? So they have built this particular application, and this application is running. Let me docker build docker run hyphen d hyphen name flask app. I'm just giving and just uh, giving 8081 to port number. Okay, and then the image name is this one. Okay, so it is running. So it started now. Okay, so they'll be accessing this particular application, and it is working fine. So the developers are able to the customers are able to access this particular application. So try to access this local host 8081. See, this application is able to access, this particular application is able to access. Okay, so everything is working fine. The customer is able to access the particular application. So this application looks perfectly fine, right? So like, if you go inside this particular the container, like, so let me go ahead and see what exactly there inside this container. Okay, so I'm just going inside the container. Okay, so if I execute ls, see, there are the files, the docker file, readme.md file, app.py, requirement.txt, test.py. If you use lsf and la, you can see .git, .git. Okay, so .git in .env file ignored because of we have written the docker ignore, right? So we are seeing all these files, right? We are seeing all these files. Okay, we are seeing all these files. Okay, so this this container is running on the production. Okay, so this container is having all these files. Okay, so are these files are needed to run your application? Okay, so absolutely not, right, not required, right? So if you want to run your application, you just need the runtime environment and your application package. So nothing else, right? We don't need any anything, right? So if you use which apt means like where you can install the packages using the apt. Okay, so which bash. Okay, so like bash terminal is also is available, so anybody coming to inside your container, so they can do whatever they wanted to do. So to accessing your application, okay, so to access your application, okay, does not need all these tools, right? So your application doesn't need this particular application doesn't need, okay, so all these tools, okay, all these tools to be there in the container, okay, to serve simple HTTP request, okay, but still these are available inside your image. These all are available inside this image. So if anybody got this cell access, they can do whatever they wanted to do, right? So this is how the people will create the insecure image where it has like security is not properly placed. And let me see. I just come ahead and see, like let me Docker images. Okay, so let me use Trivi. Let me see, is there any vulnerabilities? So because I'm having a simple the application code which I have written. Okay, so but let's see what exactly there inside this particular image. Okay, so let me see. I'm just executing Trivi, so I'm just allowing. Okay, so it will connect to the database, the vulnerability, the common vulnerability database. So it will pull all the updated the information from that data, from that particular database. So so you can see there are high vulnerabilities, common vulnerabilities. So this is the number. Okay, so this is high risk. So these are all the low we can ignore, like. So if there are any high vulnerabilities, critical vulnerabilities, we should consider and we should solve them, right? So these are all the vulnerabilities inside your application. Okay, inside your application, because this application running inside your docker container, right? Like, so which is created by a Docker image. So see, these are all the vulnerabilities which this particular the image has. Okay, so inside this we are using the Python image, so which has these many vulnerabilities. Okay, so that's what, like, so once you deployed your application onto the production, the security come into the picture. So they have scanned, so they have generated this report, and they'll share with the developer. So you can see these many high high vulnerabilities, critical vulnerabilities are there in your the Docker image or on your application. So just go ahead and look into these particular the vulnerabilities. Okay, so this is how the developers write insecure the image. Okay, the developer write the insecure image. Okay, so that's what we should be careful while developing the Dockerfile. Okay, while developing the Dockerfile. So 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 inside, whenever you build, so these many files are not required, and the tools are not required. And because of the tools, unnecessary tools which are not using, so those tools are be there in the container, is it doesn't make any sense, right? So that's what, like, so let me if you consider like, if you consider like, for example, we are building an house. Okay, so we are building a house. Okay, so let me take this. Okay, so we are building the house. Okay, so we are building the house. We are building the house. Okay, so so while building the while constructing your home, So you need cement, right? You need cement. Okay, so you need the machines, drill machines and all. You need the machines, right? You need the drill machines, and you need the workers. You need the workers. And like, so if you are doing the paint and everything, so you will be having the paint buckets, right? You'll be having the paint buckets. Okay, so so after completing your house, okay, after completing your house, okay, so do we need all these tools which we use to construct our home in our house? Of course not, right? So we don't need all these tools which we have used to construct our house. Okay, the same way the Docker will work. Okay, the same way, the exact same way the Docker will work. Okay, so like, so for example, you are building a Python application, right? So like, so in the Python, you are creating this particular image using this container. So you are developing the Python application. So what you need in this particular the container, you need app.py. Okay, app.py, where your code is running, and the Python is installed in this container, right? Python is running inside the container. And what are um, the required tools, libraries which are needed, that needs to be installed in this particular container. So other than these three, do we need any bash? Not required, right? Do we need any like apt tools? Not required to run your application. Okay, so you don't need all these packages. You don't need to curl. You don't need to wget. Okay, all these tools are not required. Okay, so that's what. For example, you are building a Java application. You are building a Java application. To build Java, so you need the build tool called Maven. Okay, so inside this container, so inside this container, you will be having Java. Then using this Java, you will create a jar file or var file. Okay, so while for build, okay, you need the build tool, and the dependencies like pom.xml. Those files should be there in this the container. So where the jar file will be created. To create the jar file, we need the build maven tool and pom.xml and the other dependencies libraries. So but to run your Java application, okay, what exactly you need? You need a JRE, Java Runtime Environment, and your jar file. These are sufficient, right? You don't need Maven to be run inside this. You don't need to be run bash in this. You don't need to run curl. You don't need to Dockerfile inside this. You don't need all the unnecessary libraries inside this. Okay, so once you build, from this build, you need to take only jar file inside this. Okay, you don't need this part. Then your customer can access only this particular application, not all this, right? Okay, so let's see how we are going to write this Docker file. Okay, let's see how we are going to write this particular Docker file. Okay, so let me go ahead and uh, write the file called let me open the Docker file. Okay, let me open the Docker file. So let me vim Dockerfile, and here we have these many files, right? Okay, so let me go ahead and create a new Docker file. Okay, so I'll use vim Dockerfile hyphen multi. Okay, so I'm just using Docker multi. Okay, so inside this, what I'll write from, okay, from Python, okay, 3.12, or you can use anything. Okay, so you must use as okay, as builder. As I mentioned, this is the build container. From that, we will install all the requirement tools, whatever the requirement library, like required libraries we install. So we will also see the Java example as well. Okay, so where you will get clear picture as well in that. Okay, so and then write Docker work there. So and I'm just that slap app. Okay, so and then I'm just copying, um, requirements.txt to current directory. Okay, and then I'll install whatever the required libraries inside this container. Okay, so let me pip install if an no cache. Okay, and then if an prefix. I'm just use I'm just installing all these tools inside this slash install directory. Okay, so -r requirements.txt. Okay, requirements.txt, and then I'm just copying all the files to in this container, right? So this is the stage one. Okay, this is what the stage one we have built. Okay, so what I have already told that, like, so this is considered, this is the stage one. Okay, so installing all the required libraries, okay, as a stage one. Okay, so and then we will take this, this is a stage one and this is stage two. Okay, so we need only the part where we have installed the required the tools inside this stage two. We don't want all this requirement.txt, Dockerfile, all these I don't want. I want only the installed required installed the stage only. Okay, so I just want to copy from this stage to this only required packages which we have installed this container, which we have installed in this container. We will just copy to this, and from this the final image will be generated. So this image will have only the required installed packages and your Python code. Okay, so this particular image. So then if you create a container, this container will not have any requirement.txt, Docker file, .git file, all these files will not be having. That's what we are building it. Okay, so from okay, so I'm just using Python 3.12, and if you use slim, okay, so the base image size will be very less. Okay, work dir slash app. Okay, so and then I'm just copy hyphen from. Okay, hyphen from. So the stage name is builder. I just given as a builder, right? So I'm just taking this builder, I'm just copying this from this builder. Okay, from this container I'm just taking whatever install in this particular folder. Okay, all those packages I just want to install in this uh, directory. Okay, in this directory. Okay, and then I just want only app.py inside this current directory. I don't want anything else. I don't want anything else. Okay, so and then sorry, here there is a copy stick. Copy. Okay, so and then I'm just using cmd. Okay, so Python app.py. Okay, so let me go ahead and build it. Okay, so if you see Docker images, okay, the image size would be 210, right? The image size would be 210. Okay, let's see how it is going to work. Okay, so let me go ahead and whatever the files I have. So docker build -f docker file.multi dot and tag. I'm just giving my app v1 version. Okay, so let's see. Here, so the image is already we are using base image has very less image. Okay, so let me see. Let me go ahead and uh, go inside this container. Okay, so docker run hyphen d hyphen in my container and then hyphen p 808282 and then it's 5000 and then this is the image name. We should use this one. Okay, so the container has been created. If you see docker ps, the another container is also up and running. Okay, so if you go ahead and inside, if you go inside this container, we can see what exactly there inside this container. Okay, now we have only app.py. So okay, so since see, now we are not seeing any like all these unnecessary files inside this docker the docker container, because we are using multi-stage. In the stage one we are like excluding all the unnecessary files and we are taking only the required file. Okay, so we have another concept, like, so we have this much size, right? So like, so can we make, okay, can we make, okay, so attacks and can we make the size will be smaller? So can we do that? Okay, so we can do with that. So but we should use the Distroless images. Okay, so the Google has created these images. Okay, so if we use Distroless image for Python. Okay, so let me go ahead and take the Python Distroless images. Okay, so if you go to the Python, so you can see, you can use this particular the image. Okay, so let me copy this. Okay, so let me open this particular file and then let me see whether we can reduce the size or not. So this is control V. Okay, so let me go to insert mode. Mm, Okay, so I just copied the Distroless images. Okay, so you will get the you will get it for the Java as well. Okay, so let me build it again. So this time I'm going to use v2 version. Okay, so let's see how it is going to build. Okay, so let me go ahead and see the Docker the images. So now you can see how much it has been, how much size it has been reduced, how much size it has been reduced. Okay, so you may have some doubt, right? So what is the advantage, what is the advantage with this reduced size? Okay, so for example, you build the Docker image with the size 1 GB. Okay, so from your pipeline, your pipeline or GitHub actions, I'm just giving pipeline. Okay, this pipeline need to push this 1 GB file Docker image to the ECR repository. Okay, so here the pipeline performance will reduce, right? Because of your 1 GB of image will take little time to push this image to Docker ECR repository, right? And if you are deploying this particular 1 GB image onto the EKS cluster, this EKS cluster need to connect with the ECR repository and pull the image, So 1 GB of image will take longer time to, little bit time to pull the that particular 1 GB image. Okay, so that's what we always make sure, and we always try to reduce the size of the image as soon as possible. Okay, if the image size is reduced, if image is very less, so the deployment will be quicker. The deployment will be quicker. Okay, and CI/CD pipeline will be quicker. CI pipeline will be quicker. Okay, and your rollout. So if anything goes wrong, so your rollback will be quicker. So that's what you always make sure, you always try to reduce the size of the image as much as you can. Okay, so and if the size is reduced, some image is reduced, so it means there are some unnecessary packages we are removing, right? It means we are making our container to be more secure, our container to be more secure, right? So now I build this image. Okay, so you can see how drastic, so half of the size has been reduced if you use the Distroless images. That is the advantage with the Distroless image. Okay, so if you use run, so let me go ahead and give v2. Okay, so let me go ahead and give v2. So what is the, okay, so I'm just giving 3, and I'm just giving 3. Okay, the container has been created. So now let me see the container. If I into docker ps-a, docker ps-a, so it exists, it exited. Why? Docker, you cannot see the logs because it is not running it. So let's see. Python 1.3 cannot open the file. App Python, no such file or directory. Okay, so the issue with the issue with this particular image is with the version. Like let's see this error as well. So why we are getting this error? Okay, let me go to let me open the Docker file. Okay, and so me um, so uh, let me build this again. Train. Let me go to Docker run again. Three. So Docker PS. So still it has exited. Let me see Docker logs. It is saying Python 3.13 as the command which is using by the Distroless image. And let me do one thing. Go and change this, and of using install, I'm just using target folder is this one, and where what can I change? I can give environment. Should I give here Python path equal to slash install? I'm just changing the like the Python path which is given by the Distroless image. So I'm just changing it, and maybe they were not having this particular this one. I'm just using the same. Okay, so and this will not using by Distroless image. Okay, now go ahead and build this. So let's see how it is going to work. Okay, Docker run. Where is the Docker run? Docker run my app for. Okay, so I'm just changing the container name 6. So let me see Docker PS. So the now the Docker container come up. Okay, so this is how we need to use the Distroless image. Like so this is the issue with this built in by this particular image actually. So which is developed by the Google. So they are using different path and they have some restrictions inside that. Okay, so that's what it was not working actually. Okay, so that's what I just changed the this particular path. Okay, so I just like customized it actually, like so overrided it. Okay, I just override this. Okay, so this is what you can check this in Google as well. Okay, so that's what the Distroless image like. So Docker images. So using this, we can reduce the image size drastically actually. Okay, so and if we go inside the Docker PS, so Docker ex ec-it, the container name, this one, Windows V, and then this. See what it is saying? The container is not running up. Docker PS, the container is running. Okay, the container is running. So I just given this container because of bash is not running inside that actually. Okay, so this bash is not there. Okay, so now nobody will get the access. Okay, now nobody will get the access. Okay, now nobody will get the access. Okay, you can go inside, because if anybody got the access for this container, right, so it doesn't allow the bash, so how can they log into the container? Okay, that's what it is going to work. Okay, so this is how we will build multi-stage, and why should we use Distroless images. So this is one of the best practice you should follow actually. Thank you very much.